video, I'm going to quickly break down the difference between average and instantaneous rates of change, and then show you guys an example of a problem with each one so that you understand how to differently calculate them. Let's say I launch a rocket up at an angle, and its height as a function of time is -5t squared plus 10t. That function is going to look something like this, where time is in seconds and height is in meters. The first thing I want to find is the average velocity of the rocket during the first second that it's in motion. Velocity is the rate of change of position, so we can find average velocity by finding the average rate of change of the function. We do this just using the same formula for slope you learned in algebra, delta y over delta x. Looking at the specific interval, that's f of 1 minus f of 0 over 1 minus 0, which simplifies to 5 meters per second. So no calculus required for average rate of change. Instantaneous rate of change is a little different though. Because the rocket is accelerating due to gravity, its velocity is different at every instant. Average rate of change can be thought of as the slope of a secant line, while instantaneous rate of change is the slope of the tangent. Pause the video here and try to solve on your own for this initial instantaneous velocity. Now that you've tried it on your own, I'm going to go over how to solve for initial velocity. Instead of using delta y over delta x, slope of a tangent line means the derivative, so we're going to use the formula that we already know for that. Simplifying and eventually plugging in 0 as h, we find the expression for velocity to be -10t plus 10. The last step of this problem is to plug in 0 as t, or time, to get 10 meters per second. Now that you've learned to solve for both, go test your knowledge of average versus instantaneous rates of change by trying out the CK12 practice quiz linked here or in the description below.